In this lesson, we're going to translate and classify conic sections. So here are all of the four conic sections we've dealt with, circles, parabola, ellipse, and hyperbola. But this time we've included our h and k values. Notice that we're subtracting as opposed to adding, so that's going to have an effect on the signs when we start substituting numbers in. As always, we're always subtracting h from our x because that deals with the horizontal, and k with the y because that always deals with the vertical. So this is what we'll be utilizing. So let's go ahead and try an example here. So the first thing we want to do is identify what type of conic we're dealing with. Because of the minus sign here, I can tell that this is going to be a hyperbola that we're graphing. But not only that, because of our x coming first and our minus y, this is going to be a horizontal hyperbola. So we're going to identify that this is going to be my minus h, this is my minus k, and this is going to be my a squared, and this is my b squared. So I could rewrite this as x plus 2 squared over 3 squared minus y minus 1 squared over 4 squared. This way I can see what the a and b values are going to be. But the most important thing I want to deal with at this juncture is with the h and the k values. H is always with the x for horizontal, x runs horizontally, and k always with the y because it's vertical. And that's always going to be the first point that I want to plot when I'm graphing something like this, is where my center is going to be. Unless it's a parabola, then the h and k is going to be the vertex, as you saw in the earlier definitions. So because this is minus h, and I see a plus 2, that tells me I'm going to go left 2. And now I'm going to go up 1. So this is going to be my center, and I'm going to be basing all my other points from this center point. Because my a value here is 3, and that's going to be my vertices, I would just go for 3 I would go 3 to the left and 3 to the right, because I know that this is going to be horizontal. So I would have those points. So in other words, I would have, as we can see here, a point at -5, 1, and +1 and 1. So that's going to be my vertices. Now my b values I can get from here. So from my center, I'm going to go up 4, 1, 2, 3, 4, and then down 4, 1, 2, 3, 4, and that would go right there. Now all I have to do is build my box, connecting my b values with my vertices, like so. Okay, and then we can determine our asymptotes at this point. When doing the asymptotes, when a translated conic or hyperbola, we can just go through the corners of our box. There is a way we can determine those equations of those lines if we'd like. But for our purposes, this will work. Okay, now that I have that, all I have to do is go ahead and graph it. And just like so, it goes through our vertices and follows along our asymptotes, and it works out nicely. So that's how we can graph a translated hyperbola. And you would use the same principles, be it a circle or an ellipse or a parabola. You start off with the center and then find all the other points based off your center point. In this next example, we're going to write the equation of a parabola whose vertex is at 4, -2, and whose focus is at 4, 1. So the vertex is where our h and k values are going to be on a parabola, since it doesn't have a center. And we'll base everything off that. So the vertex is located at 4, -2. So 4, -2. And I would just kind of do a rough I would just plot these points on a graph so that way I can visualize exactly what's going on here. And then the focus is located at 4, +1. So by knowing that the focus is above the vertex, I can see that this parabola is going to be opening upwards. And the reason I want to know that is because I want to know which of the two equations do I want? Do I want the vertical or the horizontal? And plus it's going to tell me what the sign of the P is. In this case, since it's opening up, my P value is going to be positive. So because this is a vertical parabola, we're going to be using the x minus h equals 4p and then y minus k. So that's the one we wanted to do. Now the h and k we already have because that's going to be our vertex. Now the focus will give us what our p value is going to be. And I can simply see that from here to here, from the vertex to the focus, we have a distance of 3. So and since it's opening up, I know that P is equal to +3. So now it's just a matter of substituting in our values. So I'll have x minus h, so minus 4. Oh, and I did forget to put the square, so let me go ahead and fix that. Equals 4 times 3, and then y minus k, so that's going to become plus 2, like so. And we can actually, what we'll do is we'll simplify this by multiplying 4 and 3 together and just writing that more simply as just 12, like so. And that would be the equation of our parabola. In the next example, we're going to write the equation of an ellipse with foci at 3, 5 and 3, -1 and co-vertices at 1, 2 and 5 and 5, 2. So I'm going to go ahead and start off by figuring out what type of ellipse we have by simply plotting these points and looking at what we have. So we have foci at 3, 5, so I'll put one here at 3, 5 right here, and we have one at 3 and -1, so 3, -1 down here. And then we have co-vertices, which are our b values in the equation at 1, 2, so 1, 2 and 5, 2 respectively. Okay, so because these are the co-vertices, we know that it goes around the foci, it's going to be a vertical ellipse. It's going to be something like this. Okay, so well, that'll look a lot better than that, but I just want to establish that in fact it's going to be vertical. So we'll use the appropriate formula, which in this case is h, or x minus h squared over b squared plus y minus k squared over a squared equals 1. Okay, so we already know, or we can already figure out what our b values are. And we can determine, well, we can determine those b values because we know that the center of the ellipse is going to be the midpoint of these 2 points. Now, either we can use the midpoint formula, or we could, in this case, we could count it out. So this one looks, pretty apparent because, if you sketch a graph, you can put a point right here. Okay, but if it's not so clear, you're going to want to use the midpoint formula. So the center here is going to be located at 3, 2, and therefore looks like we're going to have a distance from the center to one of the co-vertices of 2. So I know that that the b value is going to be, or co-vertices, we're going to have a distance of 2 from the center. Now the next task is to determine where the vertices are going to be located at, and we can utilize the formula c squared equals a squared minus b squared. Well, in order to find this, we need to figure out what c is going to be. We know what b is. So again, I can either use the distance formula in this case, or the midpoint formula, or we could look at the graph. So in this case, it looks like it'll be a distance of 3. Okay, so again, it's easy to graph, and we can kind of look at it that way. So I have a distance of 3, so c in this case is going to be 3. So we may as well go ahead and find b and c to begin with, because it looks like we will need both. And now I'm going to substitute in my values. So I'll have 2 squared equals, 3 squared rather. 3 squared equals a squared minus 2 squared. Or in other words, 9 equals a squared minus 4, and a squared is going to equal 13. Okay, so I know what my b and a are, and I know where my center is located. That's going to be my h and k. Okay, because the center is always going to be the same as our h and k, how it shifts. So I can come up with my equation, which is going to be x minus 3 squared over b squared, which in this case is going to be 4, plus y minus 2 squared over 13 equals 1. And then I would box that in. And that would be how we can find one. The next thing I want to be able to do is identify symmetries of conic sections. So basically, if you recall from geometry, a line of symmetry, you're going to have opposing sides of the line of reflection are going to be reflections of each other. So with a circle, we have an infinite number of lines of symmetry as long as it goes through the point 2, -3, or in this case the center. With the hyperbola, you have two lines of symmetry, both going through the center, where you have x equals 1 in this case and y equals 3. For a parabola, you only have one, it goes through the vertex. So in this example, that line of symmetry is y equals 3. And with an ellipse, you can have two lines of symmetry, one vertical, one horizontal. In this case, x equals 4 and y equals 2 would be our two lines of symmetry. Okay, in our last example, we're going to classify the conic given by 4x squared minus y squared minus 16x minus 4y minus 4 equals 0. So we're going to figure out, well, what kind of conic is this? It's something that's not in standard form. So if we can put it in standard form, then we can identify right away just by what the equation looks like. To start off, let's go ahead and group together our x's and y's. 4x squared minus 16x minus y squared minus 4y, and what I'm going to do is I'm going to set it equal to the constant, so I'm going to move the constant to the other side, equals 4. Okay, now I'm going to group these together like so, keeping in mind that this is like saying plus negative y squared. See if I can get that negative in there. Well, it's like saying plus negative, the minus sign. And I don't want to have a negative in front of here. So I'm going to want to pull out a -1 from here, as well as I want to pull out a GCF from the first one. So in other words, we're going to pull out a GCF out of each of these, because what we're trying to do is complete the square. So it becomes 4x, and then we'll say plus what is, what's going to be there to make that a perfect square. And then, like I said, this is a negative y squared because it was minus, and we always want that y, the square term to be positive. So I'm going to pull out a negative, so that's going to make that minus. That's going to become positive y squared. That's going to become positive 4y, and then plus what equals 4, like so. So remember, when you complete the square, you're going to take the middle term and you're going to divide that by 2 and square it. So I'll have 4 times x squared minus 4x, so -4 divided by 2, and then square that, it's going to give us positive 4, and then minus, and then y squared plus 4y, and then again this is going to give us 4 equals 4. Now what you do to one side you do to another. So I put in a 4 here, but we're multiplying it with this 4. So I need to put in a, so I need to do a 4, add in a 4 times 4, or 16 in this case. So plus 16 and minus, because this is a negative, with that 4 it's going to be minus 4. Okay, so when I simplify this, this is going to be 4. Now this is just going to simplify to x minus 2 squared, and this is a square of a positive binomial, so x plus 2 squared equals 16. Now the last thing I need to do is set it equal to 1. So I'm going to divide everything by 16, and then when I simplify this, I'll be left with x minus 2 squared over 4 minus x plus 2 squared over 16 equals 1. And seeing that this is a minus sign, and given the standard form, this is going to be a hyperbola. And then you may be asked to graph it or something like that. But right now I just want to be able to identify it. So that's how you translate and classify conic sections. And until next time, I'll see you on the flip side.